So after principle of operation, you need to know the advantages and disadvantages of certain type of instruments. When it comes to advantages and disadvantages, it is not about being able to list the advantages and disadvantages. So what people want to see here is that, do you understand that a certain instrument can be used in this process and it can't be used in another process because of the advantages and disadvantages that it has? So for instance, one of the disadvantages of a ultrasonic level transmitter is that because it uses the speed of sound to measure the time of flight, the speed of sound is then affected by the media or the pressure that is in the tank. So therefore, your logic must be that, okay, if we have a tank whereby the pressure affects or the environment affects the speed of sound, then you can say that we will not install an ultrasonic level transmitter there because of this disadvantage. Then you can choose to invest in a more robust instrument like a radar level transmitter, which gives you an electromagnetic wave which is much stronger and it is more reliable than ultrasonic. Then however, you must know that the disadvantage of you using that radar level transmitter is that the cost might be more than using a ultrasonic level transmitter. So those are the things that you should be looking at when it comes to advantages and disadvantages. Also mention things like reliability, accuracy, maintenance in terms of the maintenance package of that particular instrument. That also plays a role in the advantages and disadvantages. Also, if the instrument works very well and the technology is very complicated for the people in the plant, then that can also be a disadvantage for you. So when it comes to disadvantages, your thinking is not about listing, but you must be able to mention it from a practicality perspective. When someone asks you about the advantages and disadvantages of an instrument, imagine that you are going out to buy this instrument and you want to optimize all the factors like maintenance cost, reliability of that instrument, and that's how you then lay out your advantages and disadvantages for that particular instrument, because a disadvantage for a certain process might not affect another process that much. Then you can afford to get away with that particular instrument that is more affordable. For instance, certain companies will use a normal turbine flow meter when it comes to measuring water usage, but then they would invest in a Coriolis or a magnetic flow meter when they want to measure the product that they are going to sell or that they are packaging. So if you look at it from that way, one of the disadvantages of a turbine flow meter is that the accuracy is not that very good. But if you're just measuring water usage and water usage is not that critical in your plants, you can afford or get away with using a normal turbine flow meter and avoid the costs that are associated with using a magnetic flow meter, because with magnetic flow meters or Coriolis flow meters, it's not only the cost of buying the equipment, also the cost of maintaining the equipment can also play a role. So disadvantages and disadvantages, that's how you should approach this type of question. Or when you are learning instrumentation, when you're looking at advantages and disadvantages, this is how your mind should be thinking. This will really improve your understanding what instruments that you should be investing in and why. If you're already working as an instrument person in the plant, the advantages and disadvantages can really make you make better business decision when it comes to installation and buying of instrument. Then one of the points that you need to know when it comes to instrumentation is the installation rules. So for instance, if the interviewer were to ask you that, okay, there's a tank in our plant, blah blah blah, and this is how the tank is situated, and then would you install a radar level transmitter or would you rather install a hydrostatic level transmitter? So knowing the installation rules for instruments is very important so that the instruments that you've now sourced can work optimally with the accuracy that it is designed to have. So the installation rules really set you apart as an engineer or a technician or artisan, because it really shows a lot of wisdom in a way that you can look at certain process constraints and then be able to source the right instrument for the job, and therefore you can also save on costs. So when we talk about installation rules, it is things that you need to consider, like if I have a radar level transmitter, that transmitter must always be installed perpendicular to the surface of the material that is in the tank. So when you install it, you must make sure that the wave will not bounce or be obstructed by any elements that is in the tank. So now imagine you have bought a radar level transmitter, quite expensive, only to find out that when you install it, it will never be able to be perpendicular to the liquid that is in the tank. And now the factory needs to make adjustments, and then they need to change the fittings on the tank, all to accommodate this level transmitter that you bought. For that case, it was much better to use a hydrostatic level transmitter, depending on the material that is in the tank, of course. But those are the thoughts that you should have, or the way that you should think about it. Also, if you understand the installation rules, you can work much better with the process engineers, because if a process engineer would say that, okay, we need to install a magnetic flow meter at this point in the plant, and you know that in that area there are too much pipe bends and other pipe elements that will affect the accuracy of the magnetic flow meter, then you can be able to say that no, installing the meter in that area, it is not a good idea. So then they can find another place where they can measure the flow rate of the liquid in the pipe. So you want to install that meter in sections of the pipe where the flow has fully developed, in areas like where the liquid is going upstream and it is getting pressure from the pump, or in a horizontal section of the pipe where the flow has been developed. If you install it in an area where the flow has not fully developed, then you're going to start getting inaccuracy and the meter will give you very weird readings. So that's what you need to look at with installation rules, because if you do not apply the installation rules, it means that a company will invest in expensive equipment only to render that equipment useless because of the way that it was installed. Then lastly, you need to know the different manufacturers. Now, there can be different opinions on this, but I recommend that you do. Certain plants usually have like a go-to instrument manufacturer. So they will like say, we only use Anderson-Hauser instruments, we only use Vega instruments. So it is good for you to know the different manufacturers that are there in the industry. Also know where they are strong. So you'd find that different manufacturers are stronger in some type of instruments than the other. Also, they do offer different technologies that you'd only get with their instruments, as well as different interfaces, different ways to maintain the equipment. And also, if you were to switch manufacturers, you look at the whole package, or like the maintenance package of the instruments. So from the costs to the support and what tools that you have for you to be able to maintain and interact, calibrate the instrument, that is quite important. Then you can look at things like accuracy and also what other people are using in the same industry that you are in. So if you are making sweets, then you can benchmark with another plant that is making sweets. So when it comes to the instrumentation section of your interview, always give examples. It is much better, then you gain more confidence, and it shows your interviewers that you have experience and the right technical knowledge about the instrumentation questions that they are asking you.